All right, in today's lesson, we will learn how to simplify radicals using rational exponents, as well as simplify expressions with rational exponents inside of them. Okay, so let's get started. Rational exponents. Okay, rational exponents. As you know, right, a power has a base and something raised to it. Okay, rational exponent is an exponent that is written as a fraction. Okay, any exponent that can be written as a fraction. So you've been dealing with rational exponents, right? All it means is a number that is rational, right? So you've been dealing with rational exponents your entire career of math. You just haven't had fractions yet, right? Because I can write an integer as a fraction. Okay, so I am going to write an expression. So b stands for the base of my exponent, and that is raised to e over I. Okay? The e stands for exponent. The I stands for index. I might pause the video and write that down. Okay? So the goal here, guys, is that rational exponent has an equivalent radical expression. Okay, and I'm going to rewrite that right now. So anytime you see a radical, you could write it as an exponent with a fractional exponent, or anytime you see a fractional exponent, you could write it as a radical. So now we just have more tools in our toolbox that potentially could help us either simplify or solve something more efficiently, or now we can actually simplify problems that we couldn't before because we didn't have this tool. So we had b to the e over I. Its equivalent radical expression would be, the I stands for index, so the I is obviously going to go in the index spot of a radical, okay? And then you have the base of my exponent is inside the radical, and that base, okay, is raised to the e, or the exponent. Does that make sense to everybody? Okay? So that's just something, we have to know. Okay, those two things are equivalent. How I remember it, and, I have little kids, so we sing a lot of nursery rhymes and things. So we sing Old MacDonald, and if you know Old MacDonald, it goes, Old MacDonald had a farm, E-I-E-I-O. So that's how I remember it. E and I, and the O stands for over, so it's E over I. So the exponent over the index. Okay, so E-I-E-I-O. Just think of Old MacDonald, and you'll never forget it. Okay, let's take a look at this. Okay, so let's say, for example, I had 6 to the 1/5. Okay, I would pause the video and see if I could rewrite that as a radical. Okay, if I want to rewrite that as a radical, I know that the index is 5 of my radical, and I know the exponent of my base that's going to go inside of my radical is 1. Okay, so if I rewrote this, this would be the 5th root of 6 to the first power, and we really don't need that 1, right? But that's just to show you. Okay, so 6 to the 1/5 is the same thing as the 5th root of 6. Okay, real quick, let's go the opposite way. Let's see if you can do this one. Let's go 3. So the cube root of 23. Okay, let's rewrite that now as a rational exponent. So the base would be 23. The exponent of 23 is 1 in this case. So that'd be 23 to the 1 over the index of my radical is 3. So that radical would be written as a rational exponent. All right, here we go. So guys, since we're dealing with expressions and all we're trying to do is simplify them, we have to make sure, when are we done simplifying them, correct? Okay, so here's a list of things that we want to make sure are accomplished before we know we have simplified them. Okay, so in the directions, they'll say leave your answer as a radical, or leave your answer as a rational exponent, or it might not say anything, and you can choose, and whichever one your answer is in, you have to make sure it satisfies these things. Okay, so let's first talk about simplifying a radical. So the first one says all perfect squares, cubes, etc. must be taken out. That's something that you guys have already done, so I'm not really going to spend a whole lot of time on it. That's what you've been doing with the radical your whole math career. So the square root of 8 is 2 root 2, correct? That's all that means. So literally do exactly what you've been doing. Okay, make sure you pull out the things you can, leave the things that you can't. Okay, the second thing though is something I definitely want to make sure I talk about, and that is index is as small as possible. Okay, so the cool thing about being able to write a radical as a rational exponent is now we can simplify it even further. So for example, if you had the fourth root of 4, okay, previous to today, you couldn't solve that. You would box that up. You'd say, hey, I got that right. That's the simplest form, okay? From now on, that will not be counted as a correct answer. And the reason is we can actually write this with a smaller index, okay? So let's think about this for a second. You might want to pause the video and do this yourself, but we can rewrite this as a rational exponent, yes? So if you remember, it's b to the e over I. Remember, E-I-E-I-O. So this would be 4 to the exponent of 4, which is 1, and then the index is 4. So this is 4 to the 1/4, right? Now, there is nothing I can do to this point, but again, our goal here is to make it the smallest index. Is there a way that we could rewrite 4 with a base that is smaller than 4? Yes, right? I think everybody in here knows that 4 can be rewritten as 2 to the second power, right? So this is 2 squared to the 1/4 power. Yes, so I haven't changed anything. 4 and 2 squared, they are the same thing, correct, right? And now all I have to do is use my exponent rules, yes? So exponent rules, 2 times 1/4 is 2 to the 2/4, right? And then 2 to the 2/4, so 2/4, hopefully you can see, can be reduced to 1/2. So this would be 2 to the 1/2. And now, since 2 is in the denominator, is my index totally changed? Okay, it is. So my answer would be the square root of 2. Okay, guys, so if you're doing this at home, I might, in my calculator, type in the fourth root of 4, press enter, and then I would type in the square root of 2, and notice that they are the exact same thing. Okay, they give you the exact same number. So, guys, the Spark Notes version here right at the end is, okay, you have to make sure your answer has the smallest index possible, which means you're trying to get the smallest base of that exponent, simplify your fraction, and move on. Okay, we all good there? All right, now let's talk about simplest form of a rational exponent. Number 1, no rational exponent in the denominator. That should make sense, right? If rational exponents are radicals, can you have a radical in the denominator? No, so that should make sense. Number 2, no negative exponents. That is, over the course of your review standard work and over the course of your intermediate algebra and algebra work, you know that an exponent is not simplified if it has a negative in it. Okay, so you have to make sure there are no negative exponents. And lastly, no exponent can be greater than 1. And the reason is this. So guys, let's say we had, I don't know, let's go 2 to the 3 halves, okay? So if we went 2 to the 3 halves, let's just rewrite that as a radical and see what happens, right? So if we wrote that as a radical, this would be, what is that, exponent over index? So that's the square root of 2 to the 3rd power, yes? Okay, well, the square root of 2 to the 3rd power can be written as, or we don't even need to rewrite it, right? In here, I can see that is there a group of 2? Yes, right? So I have to pull that out. So this would be 2 square root 2, yes? So if you're following along at home, you understand that if an exponent is greater than 1, that means I have a group that I need to make sure I pull out. So for example, guys, if you looked at this denominator here, the index is 2, which means I need groups of 2, but I have 3 2s. That's what the numerator says. So that means I have a group that I need to make sure I pull out. All right, here we go. Let's do some examples, and then we'll be done, okay? I would strongly suggest, guys, hopefully you've gotten this far in the video, that I would watch the video for maybe 5 to 10 minutes. I'd take a pause, take a break, go walk around, go, get some to drink, go play with your your brother or sister. I don't know. But I wouldn't sit here and watch this for more than 10 minutes at a time. Otherwise, you're not grasping it as well as you could. It stinks that, we have to go to this and resort to this, but I think the best way to absorb this information, it's scientifically proven too that it's like if you're taking in information, you can only really take in information at about 10 minutes at a time, like if it's a lecture or something. So make sure that you take a break here, pause, get out of here, and then come back with a fresh mind. Anyways, example 1 says x to the negative 4/5. Guys, if you remember, back to simplifying simplest form of a rational exponent, remember, we cannot have negative exponents. So hopefully from your review standard work, you know that I can move this exponent to the denominator. So you have 1 over x to the 4/5, okay? And here's the problem, guys, is I have an exponent, a rational exponent in the denominator, which means that I have a radical in the denominator, and we know we can't have a radical in the denominator. So one of two things can happen. If you can see what you need to do from here, like you're really starting to understand what's going on, then do it. And if you can't, can you change this to a radical? Because you know and you've been doing rationalizing radicals since intermediate algebra, right? So whichever one works for you, I'm going to do it the radical way just so I can show everybody. But I have 1 over, so this is exponent over index. So that's the 5th root of x to the 4th, right? Now hopefully everybody in here knows how to simplify that from there. I need a group of 5. I have 4 x's. So that means I'm going to rewrite this thing. Or not rewrite it, I'm going to multiply the bottom by the 5th root of x, right? Because I need 1 more x to get to a group of 5. 5th root of x. So on the top, I'm going to have the 5th root of x over the 5th root of x to the 5th. If I simplify that, that'd be the 5th root of x over x. Okay, now, your answer or the problem started as a rational exponent. If we were in class, we do a bunch of problems where you have to give me both answers. We are not, so I'm not going to stress that too much. What I would do though, what I will do for you is show you what the answer would be as a rational exponent real quick. So I could rewrite it like this, or I could write it like that, or my answer could be x to the 1/5, again, because the exponent is 1, the index is 5, all over x. Okay? All right, there's the first example. Example 2, again, what I would do, again, maybe pause this video, see if you can try to come up with an idea or two, and then come back and watch it, okay? All right, here we go. Example 2, previous to today, I wouldn't be able to multiply these. This is another reason why we have rational exponents, is because now we can change these things and get rational exponents. So you have the square root of 17 times the cube root of 17 squared. Previous to today, you couldn't multiply those because their indexes are different. After today, you will be able to, and how we would do that is I can change those radicals into rational exponents. So let's do that. So I have 17, again, exponent over index. Exponent is 1, index is 2, times 17, exponent is 2, index is 3. So I have 17 to the 1/2 times 17 to the 2/3. The bases are the same, which is great, which means I can use my exponent rules. We know that if we're multiplying two expressions together that do have exponents, we can add those exponents together. So I have 1/2 and 2/3. I'm going to add those together. Again, if you're a little bit confused, what I would do is if you could rewrite, like if you could give yourself a more, how do I say this? Just a simpler example. So for example, 17 to the 1/2 times 17 to the 2/3 is really just a base with an exponent times a base and an exponent. Do you guys agree with me on that, right? So I could just say, oh, this, I know everybody knows how to do since you've been doing it since algebra. I'm going to add those. That's 2 to the 5th, right? This looks way easier than that, doesn't it? Right? So I would rewrite this as, not rewrite it, but I would write something that looks very similar to it, right? And something that you've seen. Notice, oh my gosh, I have to add the exponents and then apply it to the problem that you're actually doing, okay? So that's a strategy you potentially could employ. All right, so 1/2 plus 2/3. Again, if we have to if we have to add fractions, we are going to get the same denominator. So this one I'm going to multiply by 3 over 3. This one I'm going to multiply by 2 over 2. So you're left with 3 over 6 plus 4 over 6, which is 7 over 6, yes? So I would be left with 17 to the 7 over 6, right? Now that's not the answer again, because if you look at the rules for simplest form of a rational exponent, you can't have an exponent greater than 1. So guys, I'm going to rewrite that as 17 to the 7th, all of that under the 6th root. Now, if you can see this before you write it as a radical, go for it. Again, these are just examples, and you're just introducing yourself to it. So I'm going to go through things that you've obviously seen a bunch of times. So if you had the 6th root of 17 to the 7th power, you could take a group of 6's out, correct, right? So this would be 17 times the 6th root of 17, right? You have a group of 6, 1 stays in. So you could write it like this, or you can write it like this. 17 times 17 to the 1/6 power. So answer or answer. All right, last one. Last one, you have the square root of the cube root of 16. Okay? So that looks complicated, it looks daunting, but what I would suggest to you guys is make sure that if you see something like this, they're just radicals, right? And if you see radicals and you have no idea what to do, change them to rational exponents. And if you see rational exponents and you have no idea what to do, change them to radicals, okay? The better you are at switching between the two types, the easier it's going to be, okay? So I'm going to rewrite this as rational exponents because I have no idea what to do as a radical. So I would write 16 to the 1/3, right? Because the exponent here is 1 for 16. The index is 3. And then I can rewrite the inside. So the cube root of 16 is the base now, right? The exponent of that base is 1, and the index is 2. So that would be all of that raised to the 1/2 power, okay? Now I hope, looking at this, everybody kind of knows what to do here, right? Okay? So I have a power raised to a power, so I'm going to multiply those two things together. So now I have 16 to the 1/6 power, yes, right? All right, now, guys, we can write this with a smaller index, okay? So I would get in the habit of looking at my base, and if I can rewrite my base with a smaller exponent, like write it as a power with a smaller base, I would make sure I did that, okay? Because I would take care of the smallest index. So 16 to the 1/6 power, I can rewrite as 2 to the 4th to the 1/6 power, yes? Right? Okay. I can multiply those together, so that's 2 to the 4 over 6. I can simplify 4 over 6 to 2 to the 2/3. Answer. Or I could write the cube roots of 2 squared, which is 4. So it'd be the cube root of 4.